All right, let's look at a limit of a sequence. All right, so sometimes we're interested in what happens to the sequence as it gets larger and larger and larger, so we can take the limit. All right, so if you want to take the limit of this sequence here, so as n approaches infinity, right, square root of n over square root of 9n plus 5. Right? So we have that. All right, as you can see, as n approaches infinity, the numerator goes to infinity and the denominator goes to infinity, so we have to do some work. All right, so you can kind of treat it like, you can actually treat this just like the limit of a function. So if you don't like n, you can think of it this way. It's a square root of x and a square root of 9x plus 5. Right? Really the same thing, right? So, but let's see, I'm not going to write that, but here. All right, so just like the limit of a function, what we can do is we're going to look at the largest power. So it's essentially it's a square root of n. So it's a square root of n. So we're going to just try to divide numerator and the denominator by square root of n, and let's see what happens. Right? So if you do that, you're going to get this. So I'm going to leave the limit for now. All right. So square root of n divided by square root of n is just going to be 1, which is nice on top. Oops. Oop. All right. On the bottom, all right, so since it's both of a square root, so we can put it under the same square root. All right, so 9n divided by n would be 9. Right, 5 divided by n is 5 over n. So you can simplify it this way. Right, as n approaches infinity, you're dividing 5 by a really big number, so this guy approaches 0. It basically goes away. So therefore, we have 1 over square root of 9, which is 1/3. Right? So this is the limit of the sequence here. Right? How about the next one? All right, this one's a little tricky. Let's write down first a few terms. All right, so A1 is, let's see, 4 minus 1, so it's 3. And A2 is 4 plus 1, so it's 5. And A3 is 4 plus negative 1 cubed, so it's going to be 4 minus 1, so it's 3. And A4 is going to be 4 plus negative 1 to the 4th power, so it's going to be 4 plus 1, so 5. So you can see that this is just going back and forth between 3 and 5. So you can see that it's not approaching a particular number. So the limit in this case does not exist. All right, so limit of an as n approaches infinity does not exist. All right, how about the next one? All right, so you have some factorial going here. So you have a limit of quantity n minus 2 factorial over n factorial as n approaches infinity. All right, so if you write that out, so you have a limit n approaches infinity. All right, so the numerator, the starting factor is n minus 2. So the next one would be n minus 3, and so on. And they're going to end with 1. All right? And denominator, n factorial. So you start with n. Next one is n minus 1. Next one is n minus 2. Next one is n minus 3. And so on to all the way to 1. So you can cancel n minus 2, n minus 2, and n minus 3, n minus 3, and all these in between 2 and 1. All right, so what's left is basically 1 on top, and then you have n times n minus 1. But as n approaches infinity, the numerator approaches infinity, so 1 divided by a really big number is going to be equal to 0. Right? So this particular sequence approaches 0. Right? That's it. I hope that this was clear.